The question here is let I is equal to integral dx by root 1 plus sine x. In order to solve this kind of an integral, you multiply the numerator and denominator by 1 minus sine x, root 1 minus sine x. Okay, if you multiply the numerator and denominator, no, in fact, what you do here is you express this as a perfect square. For 1, you write cos square x by 2 plus sine square x by 2. And for sine x, you write this as 2 sine x by 2 cos x by 2. Okay, and then the denominator becomes a perfect square under radical cos x by 2 plus sine x by 2 whole square. Okay, so this becomes dx divided by cos x by 2 plus sine x by 2 simply. Okay, now I think I have shown you this how to evaluate this kind of an integral dx by cos x by 2 plus sine x by 2. How do you evaluate? You change um, sine to a tan. Okay, or you multiply the numerator and denominator by sec square x by 2. You not sec square x by 2, you multiply the numerator and denominator by cos x by 2 minus sine x by 2. Is that you can proceed in this way also, but proceeding instead of proceeding in this manner, what you can do here is you can write this as integral dx by root over of 1 plus cos sine x. You write this as cos pi by 2 plus x. Okay, and divided by now 1 plus cos 2x. The formula is 2 cos square x by 2. So this is root over of 2 cos square half of pi by 2 plus x, because 1 plus cos 2x is 2 cos square x by 2. Okay, so now from here you get integral dx by root 2 times cos pi by 4 plus x by 2. Okay, so
Yes,
from
sir.
here
Yes, sir.
1 by root 2 you can take out of the integration and write this as integral dx by cos pi by 4 plus x by 2. Okay, and now you can write this as 1 by root 2 times integral sec pi by 4 plus x by 2 dx. So now what is the integral of sec x? The integral of sec x I told you is log tan pi by 4 plus x by 2. If you remember, integral of sec x is log tan pi by 4 plus
Yes, sir.
x by 2. So you can write
Two.
this as 1 by root 2 times um, log tan pi by 4 plus, what is x here? X here is this entire thing. So pi by 4 plus x by 2, pi log tan pi by 4 plus x by 2. This. Okay. It's not only that, but divided by the derivative of pi by 4 plus x by 2. What is the derivative of pi by 4 plus x by 2? It is simply half. Okay. So now what you can do here is you can write this as 2 by root 2 times log tan pi by 4 plus pi by 4 by 2 plus x by 2 by 2. Okay. Plus a constant. And 2 you can break up as root 2 into root 2, and you can write this as log tan pi by 4 plus pi by 8 plus x by 4 plus a constant. Okay, plus a constant of integration plus c. And in the next step, just simplify this a little. This from this 1 root 2 will cancel. You simply get root 2 times log tan. Take the LCM of pi by 4 and pi by 8. You'll get 3 pi by 8 plus x by 4. Okay, this is what you will get.
Yes, sir.
So this is your answer. Integral sec or cosec. Uh, yes, this is sec only. Okay. Next one, number 4. The next integral here is dx by root 1 minus e to the power of 2x. So from now, remember I told you that whenever you see e to the power of x, you try to bring e to the power of x in the numerator as well as the denominator. Okay, so what you do here is you write under the radical you have e to the power of 2x. So you write this as 1 by e to the power of minus 2x. Okay. In the next step, you take the LCM and simplify this. You get e to the power of minus 2x minus 1 by e to the power of minus 2x. Okay. In the next step, you can write this as e to the power of minus 2x minus 1 divided by e to the power of minus x whole square. The next step, we have e to the power of minus 2x minus 1 and this radical, if you want to remove the radical from the denominator, you keep the radical only in the numerator. And in the denominator, you'll simply get e to the power of minus x. Now this e to the power minus x goes on top. Now you have e to the power of x in the numerator as well as the denominator. Now you can make some substitutions in order to evaluate this integral. So what you do here is, first of all, you write everything in terms of e to the power of minus x. E to the power of minus 2x can be written as e to the power of minus x whole square minus 1. Now what you do here is that t is equal to e to the power of minus x. That means dt is equal to minus e to the power of minus x dx. Okay, that means e to the power of, here you have a dx here also. So e to the power of minus x dx, which is this part, okay, will become your minus dt. This part will become minus dt. So this is integral minus dt by root over of t square minus 1. Okay, now there is a further substitution that you have to do here in order to evaluate. You can write this as minus integral dt by root t square minus 1. Okay, in fact this is under special integral, but since special integral has been removed from your syllabus, this is a standard integral actually, integral dx by root over of x square minus 1. But since that has been removed, we'll do it the normal way. So I'll say let t is equal to sec theta. Trigonometric substitution, because I see a t square minus 1, I know that sec square theta minus 1 is equal to tan square theta. Therefore, what will I get? dt d theta is equal to sec theta tan theta. That means dt is sec theta tan theta d theta. So now put it here. So you have minus integral sec theta tan theta d theta divided by root over of sec square theta minus 1. Okay, and in the next step, you can write sec theta tan theta d theta, and sec square theta minus 1 is root over of sec square theta minus 1 is tan theta. You know, tan theta they cancel. So you simply get minus integral sec theta d theta. And you know the standard integral for sec theta is sec x, in fact, is minus log uh, tan pi by 4 plus theta by 2. Right? This is the
Yes,
standard
sir.
integral. Okay, plus constant. Okay, you can, since this is a minus, you remove the minus here. You can write this as log of 1 by tan pi by 4 plus theta by 2 plus c. So this becomes log cot pi by 4 plus theta by 2 plus c. Now you put the values of theta. We are taken theta is equal to we are taken t is equal to sec theta. So therefore log cot, then what should be theta? Theta should be sec inverse t. So pi by 4
Yes, sir.
plus sec inverse t divided by 2 plus c. Also we have put a certain value of t also. T is e to the power of minus x. So you put that log cot pi by 4 plus sec inverse e to the power of minus x divided by 2 plus c. So this is your required integral. Okay, we continue with the next sum here. The next sum that I gave you was dx by 1 plus cot x. Okay, another important example here, dx by 1 plus cot x. So this one was number 5. Okay, now how to do this? Remember, this technique is very important. Whenever you get a dx by 1 plus tan x or dx by 1 plus cot x, you will follow this technique. You will change cot to sine by cos, or cos by sine in fact.
Okay, sir.
Now you take the LCM in the denominator. You get sin x plus cos x by sin x. Next, you can write this as sin x divided by cos x plus sin x dx. Okay, now the numerator, if you see, you have a sin x in the numerator, and in the denominator you have cos x plus sin x. So what you can do here is, you can write this as integral half of, you take a half, and in the numerator you write this as twice of sin x. Okay, divided by cos x plus sin x. And now twice sin x, you try to write in terms of cos x plus sin x and cos x minus sin x. How will you write this? So you take half out, and twice sin x, you write this as sin x plus cos x plus sin x minus
Minus cos
cos
x.
x. Okay, this way you write. You write sin x cos x plus sin x. Now you separate the two. Now you separate the two. That is, if you separate, you will get integral sin x plus cos x divided by cos x plus sin x, which will cancel obviously, both of them, dx. These two will cancel, plus integral, you have sin x minus cos x divided by cos x plus sin x. Okay, dx. Now if you differentiate the denominator, will you get the numerator? You will get. If you differentiate sin x plus cos x in the second integral, in this one, if you differentiate the denominator, will you get the numerator? Yes, you will get.
Yes, sir.
But
We will get.
you will get with a negative sign. But that is, what is
Yes,
the
sir.
derivative of the denominator? It is cos x minus sin x, and in the numerator you have sin x minus cos x. So what you do before substitution, you give a minus sign here. Okay, and then you change the order here. You get cos x minus sin x divided by cos x plus sin x dx. Okay, now you have integral dx is simply x. Okay, minus, now for this integral, okay, for this integral, let us call it I1. Okay, and we'll evaluate this I1 separately, and then we'll put it back. So here I1 is equal to integral cos x minus sin x divided by cos x plus sin x. Okay, dx. You put t is equal to cos x plus sin x, because you have already seen that on differentiating the denominator, you are getting the numerator. That means you get dt is equal to cos x minus sin x. Dt dx, in fact, cos x minus sin x. Therefore, dt is cos x minus sin x dx. Now put it in the this integral. Therefore, I1 here is integral. This entire numerator becomes your dt. Write this as dt, and the denominator you have taken as t. So this becomes simply log t plus c. Now you put back the value of t, you get log cos x plus sin x. Okay. So you have evaluated I1. Now put it back in I. What was I? Hence I is equal to, what was I here? See, I here was this half of x minus I1.
Yes, sir.
So put it back here. Half of x minus I1 was log cos x plus sin x, and you omit the constant in the bracket, you put the constant here outside, put the k here, because this constant and this constant will differ. Okay, because they are two different integrals. Okay, so
Okay,
that
sir.
is how you evaluate this integral. Okay, so um, hmm, that's it. I think I should stop here for today.